Hello. Monish, can you hear me?
Yes, sir. I can hear you.
Hi, Monish. Good evening.
Good morning, sir.
Let's wait for the other people to join and then we'll start the session.
Yeah, okay, sir.
Okay, sure. If you have any questions, though, you can ask me from yesterday's session if you have any doubts.
No questions, sir.
Okay, sure. Hi, Matan, can you hear me? Matan Chandrasekhar.
Yeah, I can hear you.
Hi, Matan. Did you attend yesterday's session?
No, actually, I just came to take up the demo session with you. So, I mean, the guys shared the link. So, not sure is it right time to join or you want me to drop? I'm happy to do that.
This is not a demo session. This is the live session, classless session. So we had the first class yesterday, and today is the second
Okay.
class. So what you can do is, like, we are taking basic networking classes today as a prerequisite class. So if you want to stay, you can stay in the class and listen to the class. It's totally completely fine. And if you require a demo separately, we can arrange a demo tomorrow at the same time.
Yeah, maybe let me see the demo because I want to see the content, whatever topics that you are going to cover, and I have a few questions to be asked to you. So it will be good if we have a demo before we are proceeding further.
Okay, then let's do one thing. Let's take a demo tomorrow. This is the content. Just a second. You can ask DURGASOFT Labs to share this PDF file with you. These are the course contents. Just a second. Let me zoom this out. Yeah. I hope the screen is visible.
Yeah.
So these are the contents for the certified ethical hacking course. What we are discussing today is basics of networking concepts, and then we'll go with the other concepts of Linux and Windows commands, and then we don't go into the cybersecurity concepts. So yeah, you can join the demo tomorrow if you want to proceed further. And what today we are taking is the networking concepts class.
Okay, fine then. Thank you so much. And the tomorrow session is going to be same timing, right?
Yeah, it's going to be at the same time, 7.
Yeah, fine. Final one question. Does
Sure.
all the days of training will be shared with us as part of recording? Because there might be an opportunity where we might miss our session. So is that possible?
Yeah, not all of them. For the sessions that you miss out, the recording will be shared.
Oh, okay, fine then. Thank you so much.
In the class, you'll have the live session. If you miss out any recording, if you miss out any session, the recording will be shared. That's not an issue at all.
Yeah, fine. Thank you so much.
Sure, man.
Yeah, bye.
Bye-bye. Malaya, can you hear me? Malaya, Shaul Singh. Monish, can you hear me? Malaya doesn't seem to be hearing my voice. Is there an issue with my audio or the student's audio? Oh, okay, Manya. Thank you so much. Okay, perfect. Okay, guys, let's wait for two more students. I guess there's two other people to join. We'll wait for them and then we'll start the session. Any doubts in history session, Malia? If you want to ask any questions, you can ask me right now, since we have free time until the others join. Oh, sure. Amit, can you hear me? Hello. Hello. Amit, maybe you have to connect your audio. Okay, guys. Okay, for all the 4 of you have joined, I hope you can hear me. Any issues with the audio, guys? Can you hear me? Hello. Hi, Rajiv.
Yeah,
Good evening.
Mohammed, we are able to hear you.
Oh, okay, perfect. Before we start with the session, guys, 2 agendas to discuss. Let me do one thing. Let me share my WhatsApp number so that I can ping you if in case there's any delay with the session or if there's anything. Firstly, 768. Guys, I've shared my WhatsApp number with you in the chat. Have you received it? 76800697768. I would recommend any one of you to create a WhatsApp group if that's okay, and add me to that group so that all of us can communicate on the go on WhatsApp, just in case if there's any delay. Hi Rajiv. Can anyone take up that task for me, please? I've shared my WhatsApp number so you can communicate with each other. Or let me do one thing. Just a second. Let's do that first and then start the session. Okay, Rajiv, can you do that? Can you take up everyone's WhatsApp number and create a group for us? Monish, Malia, and Amit, can you share your WhatsApp numbers to Rajiv in the chat so that he can start a group for everyone on WhatsApp so that if there's any updates, I can let you know. Second agenda for
Yes,
today.
yes, yes. Yeah.
Oh,
I'm
okay,
sharing
sure.
my number, Mohammed.
Okay, sure. One more thing on the agenda is we usually take demo sessions from 7 to 8, guys. So is there a possibility that we can shift our class by 1 hour from 8 to 9 for everyone? Is this okay with everyone? Amit, Malia, Monish, and Rajiv. We are taking a session from 7 to 8 right now. So what we usually do is take a demo from 7 to 8 and classes after or before that. So there's a free availability slot after from 8 to 9. So is that okay with everyone? Monish, Rajiv, Malia, and Amit. Okay, Rajiv says it's okay, better. Malia says okay, better. Amit and Monish.
Okay.
Sir, can you say it again?
Hi Monish, I was telling you that we have a demo from 7 to 8 usually every day. So it's planning on shifting the class by 1 hour. So right now we're taking it 7 p.m. to 8 p.m. How about 8 p.m. to 9 p.m.? Will that timing be fine?
Yeah, good sir. No problem.
Oh, okay, sure. So from tomorrow, what we'll do is we'll take the class from 8 to 9 every day. And Rajiv, I hope you have received everyone's WhatsApp number. If possible, please try to create a WhatsApp group and add me in that group as well. Let me send my number again. That's my WhatsApp number. And I hope everyone is added on WhatsApp so that I know I can contact you if you're running late for the session, or if I am running late for the session, I can inform you on WhatsApp. Texting you by email would be not everyone would check an email at the earliest, so it's better if we contact on WhatsApp. Okay. Yeah, Amit, do you have a question? You have raised your hand. Any question, Amit?
No. Sorry, it was by mistake. I just clicked on that.
Oh, okay, sure. No problem. Okay, guys. So let's do one thing. Let's start the session without any further ado. Before I start this session, one common question I ask is any questions from yesterday's session, and does anyone have any doubts before I proceed with today's class?
So yes, Muhammad, I have few doubts. Like suppose in class D and class E, you mentioned like it was used by I mean to say R&D purpose or military services, and there is no host connection in class D or class E. So how they are
Okay.
going to communicate without host?
Not necessarily, as I've told you, that is each IP address itself is forming a network over there. And when you connect from one public IP to another public IP, you never require a host over there. Okay. Internally in their
Okay.
organization, they can use private IP addresses. As well for the servers and stuff, they can always go with public IPs. And when you connect from one public IP to another public IP, you never require a network over there. Okay. It's just one, it's as if you're connecting to Google website by using the IP address or by the domain, you can directly connect to it. In their local organization, they can use their private IPs again.
Okay.
Okay,
Got it.
Yeah, just like how we use our private IPs in our local networks, in our home connections or offices, they can use private IPs as well. For the main or office servers or something, they can use the public IPs from class D and class E.
Okay.
Any other questions, guys? Amit, Malia, Manish, Rajiv, before I begin with today's class where we'll discuss with subnet mask. Okay, sure. Assuming that no one has any questions, we'll proceed without any further ado. Now, in today's class, let's discuss what subnet mask is. So in yesterday's class, I've shown you how to check your private IP. So what I've done is I've gone to my command prompt, and in the command prompt, I've given the command ipconfig, and this shows me four values. Firstly, it shows me my local IPv6 address. This is how an IPv6 address looks like. Again, don't worry about this, guys. We'll discuss this shortly. Okay. Then there's IPv4 address, my machine, which is getting an IPv4 192.168.1.3. Now below that there's something known as subnet mask. Okay. Now what is the relevance of the subnet mask and how is this important for us? Okay. Now we humans, when we understand IP addresses for class A, class B, and class C, we are defining them with network and host portions, right? So we tell that network class A has one network portion and it has 3 host portions. Class B has 2 network portions and it has 2 host portions. Class C has 3 network portions and 1 host portion. But how would a computer understand which class an IP address belongs to? So for computers to understand, what they did was they gave the value of network portions to 1 and they gave the host portion value to 0. So that even if the host portion value changes, it doesn't affect, it still belongs to the same network. But if the network portion value changes, the network completely divides over there. So they gave the network portion values as 1 and the host portion values as 0. So whenever I have network portion in class A, I have assigned all the bits in that octet to 1. Okay, so the first 8 bits in the first octet of class A is all 1s and the rest of the host portions are all 0s. Now, when you convert this number from binary to decimal, you can know that all 1s is nothing but 55 and all 0s is nothing but 0.0.0. Therefore, when you specify a subnet mask of this value 255.0.0.0, the computer knows that this is a class A address. Okay. When you specify a subnet mask of 255.255.0.0, the computer knows that this subnet mask is of class B and that IP address is also belongs to the same class. Okay. When we talk about class C finally, excuse me, it has 3 network portions and 1 host portion. So I have to put all 1s in the first 3 portions and all 0s in the last portion. Therefore, the subnet mask is 255.255.255.0. And if you notice over here, the IP that I'm getting 192.168.1.3 belongs to class C. If I scroll up a bit, you can notice over here the class C range 192.168 IP. Therefore, this is class C, and therefore I have the same segment mask that belongs to class C 255.255.255.0. Is this clear, guys? All of you? Mani, Malia, Amit, Manish, and Raji. Okay, cool. Now coming to the next value, let's understand how to manually assign the subnet mask and how to assign these IP addresses. As I've already told you, when we talk about public IPs, our IP addresses are given to us by the public IPs by ISP, Internet Service Provider. So whatever Internet Service Provider you have, whether it be Airtel, Idea, Hibernate, BSNL, or in US you might have something as T-Mobile, Verizon, AT&T. These ISPs are providing you your public IP. Okay, so if you open up your browser and if you search for what is my IP, this shows you your exact public IP. Okay, now when we talk about private IPs, we can assign our private IPs manually. Okay, so when we talk about local network, there are two ways of assigning an IP address. One way is the automatic method. Okay, how do we assign private IPs? One method is known as the automatic method, where you have something known as a DHCP server, which dynamically assigns your IP. So we'll discuss about DHCP later. First, let's discuss about how to assign an IP address manually. Okay, so in your local network for your device, you can manually assign your private IP. Okay, so if you're a network admin as well in your organization, it is your task to manually assign a private IP to every machine. But if it is a big organization, then we usually go with the DHCP server. So let me show you how you can assign a private IP manually first. Okay, so the process is pretty simple. You all have to go to your control panel first. Okay, you can search for control panel. That opens up your control panel. In the control panel, you have to go to your network and internet setting. So in control panel, go to network and internet. Within that, go to the first option, network and sharing center. And within that, go to the option change adapter settings. Okay, so right now you can notice over here, I'm connected to my Wi-Fi network. Okay, I'm accessing my internet via my Wi-Fi interface. So I'll select the same interface over here. I have a lot of interfaces also, you can notice. My Bluetooth interface, my LAN interface, ETH0. There is another ETH0 interface for my VPN. Oh, just a second, guys. Excuse me. Yeah, and there's my Wi-Fi interface. This is the interface for which I'm getting my IP address over here, 192.168.1.3. Okay. Now this IP is being assigned dynamically. If I go to properties, in order to check my IP address, how am I getting this IP dynamically or by manually? I can go to the IPv4 settings and I can click on properties. And over here, if this first option is selected, obtain an IP address automatically, it means that you are getting an IP address from the DHCP server. So right now, my Wi-Fi router itself is acting as the DHCP server, which is giving me an IP address automatically. Okay, don't worry what DHCP server is. We'll be discussing that shortly in a couple minutes. Okay. If you want to assign an IP address manually, then we'll go with the second option. Okay, and then you will specify the IP address that you want. So right now, I'm getting my IP as 192.168.1.3. Let's say if I wanted to assign an IP address from a class A, can you guys tell me a private IP from class A? Anyone? Or you guys, Ahmed or Malaya or Manish or Raji, can you let me know a private IP from class A? Perfect answer.
10.0.1.
Exactly, 10.0.0.1. If I click on subnet mask, yeah, guys, hello. Yeah, to 10.255.255.255. That is the last IP. Any IP between that is a private IP from the class A range. Okay, perfect answer. Absolutely correct. I hope, guys, you have tried to remember all these values. It is important that you memorize this. Okay, all the different classes and all their private IP ranges. Okay, please try to memorize these. It is important for us. Okay, and now coming back to this page, now I've assigned a class A IP over here. And if you notice, if I click on subnet mask, it automatically allocates 255.0.0.0. This is a class A IP subnet mask. Okay, if I give a class B address, can anyone tell me a class B private IP?
172.16.
172.16.
172.16.32.1.
Yeah, anything is perfect. 172.16, that's a correct answer. And now when I click on subnet mask, you can notice it is giving me class B subnet mask 255.255.0.0. Now when I click on class A, when I give a class A address over here, class C, which is 192.168.1. So I'm already getting 1.3 So what I'm going to do now is I'm going to assign a different IP, let's say 1.100. Okay, and subnet mask is 255.255.255.0. Now there's another address called default gateway. As I've explained yesterday, default gateway is nothing but the address of your router. So your Wi-Fi router is acting as a gateway, intermediate body between your local network and your public network. So this machine is asking, who do I contact when I want to connect to the internet? That's why you have to mention the router address, and the router address is 192.168.1.1. By default, the router will always get the first IP in the network. Okay, so I'm going to put the same IP 192.168.1.1. Okay, again, now there's another setting called DNS server. Guys, don't worry what a DNS server is. We'll be discussing this as well after DHCP. Okay, but by default for now, I'm going to use my Google DNS server, which is 8.8.4.4. Okay, so this is the default DNS server for Google. If you open up your browser, you can search for Google.
So can we take 8.8.8?
You can
Yeah,
you
yes.
can either take 8.8.8.8 or 8.8.4.4. Okay, so these are two DNS servers from Google, and I'll explain you what DNS servers are shortly. No worries. So for the time being, I'm using a Google DNS server. Let's click on OK. Once I've clicked on OK and close, guys, can you hear me? Am I audible? Since I've changed my IP, that might cause some interference. I hope you can hear me, guys, all of you.
Yes, sir.
Yes, yes.
Okay, now if I check my IP address again, now you can notice I have got the IP that I set it, 192.168.1.100. Okay, so this is how you can manually assign an IP address of your choice in your network. Okay, and if you want to connect to the internet, you have to assign the proper DNS server. Okay, which is I've used the Google DNS server over here. Although if not, your router can automatically assign the DNS server as well. Now let me explain what DHCP server is. So this is how you can assign your IP address manually. In order to get the IP from DHCP server, you can go to properties, you can go to IPv4, you can go to properties again and select obtain an IP address automatically. Okay, when I click on OK, again guys, you might lose a connection for a second. Okay, don't worry about it. Guys, can you hear me now?
Yes, sir.
Okay, now if I type IP config again, you can notice I've got my original IP back over here. Okay, now let's talk about DHCP server. Okay, in the olden times when networks were not so big, it was very easy to manually assign an IP address. So if you're a network admin for a small organization, you can go to each and every device and you can open up the control panel and they can assign the IP address manually. Okay, but in today's scenario, we have larger networks, and if you're a network admin and in such a larger network where you're using a class D address which contains more than 255 devices, the job becomes quite hectic. Okay, assigning a manual IP address to every machine in the network. Therefore, what they came up with was they came up with a program or a protocol called DHCP, which stands for Dynamic Host Configuration Protocol. Where is this? Yeah, over here. DHCP stands for Dynamic Host Configuration Protocol. The main importance of this protocol is to dynamically assign or allocate an IP address to each and every host in the network. Host the network. Okay, so it made the task of your network admin to give the IP addresses to each and every host. Okay, so as soon as you put a DHCP server, it will automatically assign or dynamically assign an IP address to every host, or it will automatically configure. And that is what is meant by dynamic host configuration protocol. Okay, now let's understand how this happens. Okay, so what I'm going to do is I'll open up a tab, just a second. Let me show you this in a diagram. This is much better. Yes. So let's say this is my local network. I have my devices over here. This is PC1, there's PC2, and then there's PC3. Okay, and I have my DHCP server over here. In my local network, in your home network, your router itself accesses the DHCP server, guys. In organizations, what happens is they have a separate server, a separate Windows system in which there's a DHCP protocol installed. And in that DHCP server, they'll give a pool of IP addresses. Okay, So this will have a pool of IP addresses. This is the DHCP server. Okay, let me increase the font. Yeah, much better. Okay, now this is my DHCP server, and this always has a pool of free IP addresses. Pool of free IP addresses. Okay, now this address range could be from 192.168.1.2 to 192.168.1.254. Let's say I'm assuming that is the range of my free IP addresses. Okay. Now what happens is whenever you connect a new device in your same network, so let's say these are my 3 devices in the same network, and whenever these devices want to communicate, want to connect to the network, initially what they will do is they will send a D packet, which is known as a discover packet. Okay, let me give that. Yes, I will not. Okay, so first this machine, let's say this is the new machine connected in the network. So first this machine will send a packet to every other machine in the network. So this will send it to this one, this will send it to this one as well, and then it will send it to the DHCP server as well. And this packet is known as the discover packet. The main purpose of this packet is to just tell you, asking where the DHCP server is. So this machine is broadcasting a packet called discover and asking, are you the DHCP server? Are you the DHCP server? And are you the DHCP server? So if a machine is not the DHCP server, all it will do is it will drop the packet. Okay, so this machine will drop the packet. This machine will also drop the packet. But since this reaches the correct DHCP server, this machine will not drop the packet. But in return, it will send another packet, which is known as the offer packet. Okay, so this is the offer packet. It sends an offer packet back. Okay, and over here, let me write it down as offer. Okay, in the offer packet, it has an IP address and tells, hi, I am the DHCP server, and I can assign you a free IP address, which is 192.168.1.3. Okay, if you want this IP address, just let me know. Okay, once this offer is sent to the machine again sends another packet. Okay, and that is known as the request packet. Okay, so it says, thank you DHCP server for assigning me that IP address. I would request you to allot that IP address to me. Oh, just a second, guys. This is a request over here, and this is known as the request packet. Okay, it says requesting to the DHCP server, thank you for allotting me that IP address. I request you to allot that IP to me and remove it from your pool of IP addresses so that you don't assign that same IP to any other machine. Once that request is sent, the last packet is sent from the DHCP server again, and that packet is known as the acknowledgement packet. Okay, and this is finally acknowledgement, which is nothing but confirmation. Acknowledgement. This is confirmation sent from the DHCP server to the victim, to the target machine, telling that I have assigned this IP to you. Now this 1.3 IP is allotted to you, and now you can communicate in the network. And this process is known as the DORA process. D for discover, O for offer, R for request, A for acknowledgement. And this process happens within fractions of a second. Every time you connect a machine and select the option, obtain an IP address automatically, this is what happens. First, your machine sends a discover packet to all the devices in the network. If it reaches any other device like my phone or my smart TV, those devices will drop the packet because that packet is irrelevant to them. But when it reaches the DHCP server, which is my router, it tells it reaches the DHCP server and says, are you the DHCP? DHCP says, yes, I am the DHCP server, and it offers an IP address, a free IP from its pool of IP addresses. Once it is offered to the machine requests to allot that IP permanently. Once that request is sent, the DHCP server sends a confirmation message like, okay, this IP is allotted to you, and now you will get this IP. Is this clear, guys, for everyone? Just a second. Let me put up the chat.
So, Muhammad, so handshake get happened when the packet DHCP server send the discover offer packet. At that time, the handshake get happened, or during the discover time it get happened?
I didn't get your question, Ahmed. Can you please repeat it? Actually,
So,
I'm so sorry.
My question is like when the handshaking between the host and the server get happened.
Handshake usually happens at the confirmation part. So at the end, after the acknowledgement is sent, handshake happens after the complete process. First, your machine sends a discover packet to discover where the DHCP server. It is just trying to find out where DHCP is. When that packet reaches DHCP server, in response, it will send an IP. Again, in response to that, your machine will send a request telling that please allocate that IP to me and do not assign it to anyone else. Because in the same network, no two machines can have the same IP. So once that request is sent, DHCP server will remove that IP from its pool of IP addresses. And then finally, it will send confirmation, acknowledgement, which is like your handshake part. Okay. So after these 4 steps, the handshake is confirmed.
Okay. So from security point of view, so I'm not clear about it, but somewhat I have knowledge like once the handshake happened, then after both the the target machine and the host get establish the connection.
Okay.
Is this right? Or
yeah, that
I'm
is right.
wrong?
Handshake communication is possible. But more importantly, in DHCP, you would not call it as a handshake, because in handshake, you usually have TCP flags. There's something like SYN flag, acknowledgement flag, and reset flag, FIN flag. So over here, we do not have any flag data. We just have some packets being sent. So it's better not to call it a handshake, but just a connection between DHCP server, a trading between DHCP and your client machine to get an IP address.
Okay. Okay, got it. Thank you.
The task of DHCP server is just to allocate an IP address. After that, there's not much communication between DHCP and the machine. Okay. Once it has allocated an IP, that's it. That's the end of the task over there. There will be no more packet exchange between DHCP and the machine. Okay. When the packet exchange happens is after the lease expires. So if I open up my command prompt over here, let me show you my command prompt over here. Right now, I can't see DHCP details over here. In order to get the DHCP details, you have to type the command ipconfig and then /all for extra details. When you give /all, now you can see the DHCP server. So right now, my router itself, which is 192.168.1.1, is acting as my DHCP server. Okay, and this DHCP server gave me my IP address on 21st September 1928. Okay, so just a few minutes ago, the DORA process happened. Okay, while we were taking the class. Okay, when I changed the IP address and when I clicked that button, obtain an IP address automatically. So if I go to ncpa.cpl, this opens my interface page. And when I clicked on this button, obtain an IP address automatically, that is when, as soon as I selected this option and clicked on OK, that is when DORA process happened. And I got my IP address. Now this IP address will be valid for me for 24 hours. So from 21st September 7:30 to 22nd September 7:30, this IP address will be allocated to me. After that, the IP address is freed back and sent to the DHCP server. Then the DORA process happens again, but you won't notice that. It happens in a fractions of seconds, and you won't even notice that happening. Okay. The reason why there's a lease obtained and lease expired is sometimes after an IP address is allocated, if the system is shut down, that IP address is being wasted over there. So after, even if the system is not in use, that IP address is allocated to the device. Therefore, after lease expires, the IP address will be freed back and given back to the DHCP server so that that can be used by other devices. Okay, so this is what happens. And at the moment when lease is obtained, DORA process happens again. After when lease expires, DORA process will happen again if the device is switched on. Okay, so that is the only 2 points of time when DHCP server and the clients will communicate. Other than that, there's no communication between the device and the DHCP server. Is this clear, guys? Hello.
So Mohammed, can we customize the timeline like as you said it's valid for 24 hours, so can we optimize up to 4 hours, 6 hours?
Yeah,
like
sure. You can optimize that. Right now on my router, if I log into my router admin page, in that you'll have a DHCP server setting. Again, if you're connected to your Wi-Fi, you can access the website 192.168.1.1.0.1, whatever your router IP address is. If you access that, so right now my router IP address is 192.168.1.1. So if I open that in my browser, 192.168.1.1, this will open my browser page. Advanced, accept this, confetti. This is my router page. So I can log into this. Once you log into that, you'll have a setting called DHCP settings. Okay, and in that you can modify all the settings for how long you want the lease to be, or what is the pool of IP addresses you want to define. Do you want to use all the 254 IPs or only the first 100 IPs and so on? Okay, so you can do that and change all the DHCP settings. If possible, let me show that as well. password. You can easily guess what my password is right now. And just a second. I've never changed the DHCP setting for my device, but LAN status. Yeah, DHCP as you can notice. So right now, what I'm doing is I'm using all the 253 IPs in my device in my server. Okay. So my router itself is acting as my DHCP server. And if I want to modify that network LAN settings, yeah, over here you can notice DHCP enabled. This is the start IP. This is the end IP. Okay, and DHCP lease time 86,400 seconds. But this is nothing but 24 hours. 24 hours converted to seconds, which is nothing but 86,400. So my lease time over here is 86,400, which is 24 hours. If I want to increase that from 24 hours, I can modify it depending on the seconds. Okay. And this is the start IP of the pool. This is the end IP of the pool. Amit, is this clear? Hello.
Yes, Mohammed. It's clear now.
Okay. Okay, sure. Amit, Malia, Monish, Rajiv, any questions how to modify the DHCP server settings? Right now in my home, my Wi-Fi router itself is a DHCP server, and these are the settings for my DHCP. This is the starting IP 1.2 because 1.1 is always used by the router, and the last IP is 254 because 255 is also not used. First IP 1.0 and last IP 255 are never used. Okay, the only valid IP addresses are from 1.1 to 1.254. Okay, and this is the range of my DHCP pool, and this is the lease time. So after every 24 hours, the DORA process will happen again and again. Okay, that is very necessary so that. Yeah, who is this? Oh, Rajiv. Yeah, go ahead. Yeah, go ahead, Rajiv.
How the manufacturers allocate a particular IP to open its web server page, like here it is 192.168.1.1. How is this IP is allocated?
I didn't get your question, Rajiv. This is a private IP. I can change that to whatever I want to. There's nothing that a company has said.
No. Actually, on opening the admin page, web server page, we just log on to 192.168.1.1. How this IP is allocated to open that web server page?
Because that is the IP of my router. So when I'm setting up my router, I set up this IP. So when you take an internet connection, that guy comes and sets up your router, right? So when he's setting up the router, you can assign that IP manually. So what he did was he assigned one dot network. Usually sometimes what happens is it's either one dot network or zero dot network. It could either be 192.168.1.1 or 192.168.0.1. Okay, so that is assigned by the person who's giving you the internet connections. Although if you want to change that, you can manually change it over here as well. So right now my primary address is 1.1. If I give 0.1 over here, it will automatically change. Okay, and depending on that, I have to change the rest of the settings as well. If this is 0.1, I have to make this 0.2 to 0.254 as well, so that all my devices in the same network belong to the same, can easily connect to my router.
Okay, sir.
So here you can change. Okay, Monish and Malia, any questions for you guys? Okay, Malia has no questions. Monish, any questions for you? Hello, Monish, can you hear me? I guess you have muted your mic. That's why I can't hear you. Okay, guys, can you hear me? I guess there's some audio issue with Monish. I can't hear him. Although I hope you guys can hear me. Okay, sure, no problem. So I hope, Monish, you have no questions. Although if you have any questions, you can let me know and I'll clarify that. So this is about DHCP server. Let me log out now. This is not necessary anymore for me. I'll close this and this as well. Now let's talk about DNS server. What is DNS server and how it is useful? Part 5. Yep. So I guess you have understood the DORA process, guys. As I told you, this DHCP server works on DORA process. In DORA, D stands for discover. Let me write that down as well. D stands for discover. This is the main task of this. It's the host broadcasts broadcasts the discover packet to every machine in the search of DHCP server. The search of DHCP server. Okay. After that, there's O, which stands for offer. This is sent in response. This is sent in response from the DHCP server. DHCP server to the client. The client who is broadcasting the discover packet. Okay. Then there's R. This is request sent from the client. Now this is unicast. This will not be broadcasted once the client knows where the DHCP server is. This will be sent from the client directly to the DHCP server. To request the allocation of the IP address. Finally, there's acknowledgement A. This is confirmation. Acknowledgement. Confirmation sent from the DHCP server to the client with the allocated IP address. Okay, so this is the DORA process. This is how it happens. Although, guys, if you want to take a screenshot, you can take a screenshot of this diagram. Okay, because in the notepad file I can't send you any diagrams. So if you want to take a screenshot, again, so sorry for the terrible drawings. I'm a very bad artist, so I hope you can manage with this. Okay, so shall I proceed, guys? Can I move to the next concept, the DNS server?
Yeah, please, sir.
Okay. Now coming to DNS server. Let me clear all this. This is unnecessary for me. Let me just close this. Unnecessary. Coming to DNS server, if I have to explain you DNS in the basic example, DNS is nothing but like a contact book for your websites. Okay, just like how in your phone you have contact books for different contacts. Like let's say you might have a contact like Shoaib 76800696768. Then there's another contact like let's say Manish, which has a contact number, some random contact number. Then there's reddy with another contact number. Okay. And then there's Rajiv with another contact number. Okay. Now, whenever we dial a number on from our phone, we can't we humans, it's very tough for us to remember long numbers. Okay. And definitely we cannot remember all the contacts in our phone. Okay. What we can do is we can save the contact number and assign it to a name. That is what usually happens. The contact book has a correlation between our contact name and that specific number. So whenever you dial a number, you search by the contact name and you dial with that name. And from there, your SIM card will automatically know, okay, this from the contact save that it has to contact so-and-so number, and it will reach the ISP, internet service provider, or your SIM card provider, okay. And from there, it will reach the exact SIM card. Okay? So in your phone book, your contact application is relating or translating a contact name to the specific contact number. Okay, so the ISP does not know your contact name. It is only related. It is only concerned with the contact number. Sorry. Similarly, when you open up a browser and search for www.google.com, your browser does not know what this is. Your browser has no idea what google.com is, or what yahoo.com is, or what facebook.com is. What it is concerned with is the server on which google.com is stored. And every server, every website, every domain has its own public address. Okay, so your browser is only concerned with the public IP of www.google.com server. Okay, and between your browser and google.com in the ISP, they have DNS servers, and in the DNS server they have records where for google.com they will write its own public IP. For facebook.com it will have its own public IP. For yahoo.com, and for each and every important domain they will have their own record which contains the domain name and the correlated public IP. So even if I open up a browser command prompt and I search for the command ping, ping is a command to check whether there is a connectivity between your device and other devices. So if I want to ping to my router, I can give 192.168.1.1 and I can check if my device is able to communicate with my router. And if I'm getting a reply, that means that I am able to connect. Okay. If I'm not able to connect, I will get request timed out. So if I say ping 192.168.1.99, so there is no device called 99 in my network. But if I hit ping, you can notice I'm not getting any reply. Okay, because that destination is not available. Okay, not reachable. Right. Similarly, if I try to ping google.com, PING www.google.com. This is one way how you can check the internet connection as well. You can see you're getting a reply back. And if you notice over here, I'm getting a specific IP. This is the IP of Google server. Okay. If I copy this and if I open up my browser and if I search for that IP, if I search for this IP 142.250.76.196 and if I hit enter, you can notice I'm getting Google page. Okay, so what is happening over here is this is the IP of the public server on which Google is located. But we humans don't need to remember this number. Okay, so this is like the contact number for Google. Okay, but what we're trying is we are dialing Google with its domain. So in between, your DNS server is acting as a contact application, linking or translating every domain to its IP address and vice versa. Okay, but we humans can't remember these IP addresses. That's why we have assigned a domain name to each and every website. Okay, and your DNS server in between is making the task possible to whenever you're typing the domain name or typing the IP address, it is the body responsible to send that packet to the exact server. Okay, if DNS server was not there, you would never be able to communicate to any website online. Okay, because your browser does not know what that website name is. It does not know what google.com is. All it knows is that it is a server. Okay, and that server IP address is there with IST. So whenever you type google.com, your packet reaches your router first. From there, it goes to the ISP. In the ISP, it will check the DNS server record, and from there, it will go to google.com. Is this clear, guys? Everyone? So sorry for the external disturbance, guys. My neighborhood. Although, is this clear for everyone, guys? What DHCP server is? Okay, Amit has confirmed. Malya, Monish, and Rajiv. Okay, Malya has also confirmed. Monish and Rajiv, any doubts of what DHCP server is? Okay, cool. Monish, confirmation, please. Okay, guys, I guess Monish is not online for some reason. I can't hear him. Anyways, I hope it's clear for everyone, guys. So yeah, that's it for today's session, guys. Nothing more. I wanted to show you the last topic of DHCP DNS server today. In tomorrow's class, what we'll discuss is basics of. I'll explain the lab setup part. So we'll discuss another address, which is MAC address, a permanent address. And after MAC address discussion is done, I'll share you all the lab setup files and I'll assist you in the lab setup. I'll show you how to install the lab on your machine. Okay, and you can replicate the same process on your device. Okay. So before I end the session, since we have a couple more minutes, 2 to 3 minutes more, let's do one thing. Let's set up our WhatsApp group. Okay. So Rajiv, if it's possible, can you add your contacts now and set up the group before I exit the chat? So that by tomorrow I can contact you on the WhatsApp itself. Hello. Oh, already created, Rajiv. Let me check that. Just a second. Cybersecurity. Oh, okay, perfect. Thank you so much, Rajiv. Thank you so much for doing that. Yeah, okay, there's Rajiv. There's 85272. Who's this? 8527. Okay, okay, Rajiv. Okay, I guess everyone has been added. There's 5 participants. One is me, and the rest of them are you students. Okay, sure. Thank you, Rajiv. Thank you so much. Yeah. So Yeah, Rajiv, from tomorrow, I'll show you the lab session part where I'll explain you how to create a lab on your machine, and we can do the lab setup in tomorrow's session. Before that, there's one small concept called MAC addresses, and once that is done, we can go with the lab setup installation. Okay. And yeah, I'll send this class as well, guys. I've already sent this notepad file, but I guess I've added some content, so we can I'll send this file as well. And yeah, tomorrow's class will be from 8 p.m. guys, not 7 p.m. Important update from tomorrow, the class will be from 8 p.m. to 9 p.m. Okay. We usually have demo sessions every day from 7 to 8. That's why I cannot give you that time. But after that, I'm completely free. So from 8 p.m. to 9 p.m. we'll have our classes as regular from tomorrow.
Sorry, sir, I can't understand, sir. Tomorrow the class will be 9 or 7 to 8.
It will be from 8 to 9, 8 to 9 a month. From tomorrow, every day we'll have the class from 8 o'clock to 9 o'clock.
So then just told the DurgaSoft sir to share the link for the classes from 8 to 9. Because today
Yeah,
I
sure.
have registered, sir.
Yeah, sure. I guess you can use the same link. If not, I'll update you with the latest link and I'll put it in the WhatsApp chat. Okay, Manish? Okay, Amit? Got it,
Yeah,
sure.
this will be better, sir.
Okay, sure. I'll put the latest link in the WhatsApp chat. No issues with that.
Okay, sir.
Okay, sure. Thank you so much, Amit. Thank you, Malaya. Thank you, Manish. Thank you, Raji.
Thanks.
Tomorrow the class will be at 8 and I'll share you the link. If the link is not shared, you can use the same link which you're already using. Okay. But if there is any update in the link, I'll update in the WhatsApp at the earliest. Okay.
Sir, but on the registration page, sir, we have to select the time slot, sir. It is allocated 7 to 8 p.m. That's why.
Okay. Sure. No problem. I'll see to it that there's update in that. So I'm pretty sure they'll make a change in that and you can use the same link. If there's a change in link, I'll update you with the WhatsApp chat. Not an issue.
Okay. Sir, what topic we will discuss
Okay.
tomorrow?
Tomorrow we'll discuss about MAC addresses. Let me show you tomorrow's class as well. I have the file. Windows C. Just a second. I'll share you the text pad file. So these are tomorrow's class topics. We'll discuss about MAC addresses, and after MAC addresses, we'll discuss about spoofing of ID. We'll discuss this later. Before that, I want to show you the lab setup. So we'll learn about VMware installation lab setup, and after that, we'll go with the spoofing concepts. Okay. So tomorrow's session might be a bit longer, guys. It might be a bit longer than 1 hour. We'll discuss about MAC addresses and lab setup installation. Okay. Any other questions, guys?
Sir, means tomorrow classes is very important because
Yeah,
less
lab setup.
there.
Exactly. Tomorrow's session. Don't worry. Again, it's going to be as easy as possible because what I'll be doing is I'll be sharing you a PDF file, and in that PDF file, just a second, let me show you that. For the lab setup, what I've done is since the procedure is long, what I have done is I've created a PDF file, and I'll be sharing this PDF file with you at the end of the session. And this PDF file contains the step-by-step procedure of the installation. Okay. So whatever steps I take in the class, what I've done is I've taken screenshot of each and every step, and I've given a description of what you need to do in that step as well. So I'll be sharing this PDF file, which contains 24 pages. Okay. And this PDF file is containing each and every step of the installation process. So you don't need to worry. If you're getting stuck, you can always refer to the PDF. If you still have doubts, you have a contact number. So you can contact me at any point of time when you're stuck at any installation
Is there
process.
software also, sir? VMware software.
Yeah. I'll be sharing you all the software. I have all the software uploaded to my Google Drive. And in tomorrow's class, I'll be sharing all the software as well as all the PDF files required. Don't worry, guys. Don't worry about any part of the installation. I'll be assisting you in all ways possible. Okay. Okay, sure. So that's it for today's session. Tomorrow we'll take the class at 8 o'clock, and I'll be sharing you. If there is an update in the link, I'll share you the updated link in the WhatsApp group.
Okay, sir.
Okay, sure. Thank you. Bye-bye. See you tomorrow. Take
Bye,
care.
sir.
Have a great day. Bye.
Bye. Good night.
Yeah, guys. Good night, guys. Take care. Have a great day.